the last class, I was discussing motion in a straight line. So basically, in 1D motion, what is the meaning of accelerated motion? So there may be two type of accelerated motion. One will be, can anyone tell me what will be the type of accelerated motion? First is uniform accelerated motion. Uniform accelerated motion. Uniform accelerated motion. And second will be non-uniform accelerated motion. Second is non-uniform accelerated motion. Non-uniform accelerated motion. Accelerated motion. So, what is the meaning of uniform accelerated motion? Uniformly accelerated motion is acceleration throughout the motion, it will be constant. Direction as well as magnitude of the acceleration, that should remain constant. Basically, magnitude and direction of the acceleration, that should remain constant. So if its magnitude is constant and direction is constant, then which equation you are going to use to solve the questions, to understand the kinematics of motion? Which three equations you are going to use? So remember this, whenever acceleration is constant, only then you can use these three equations. V equal to u plus at, ठीक है, s equal to ut plus 1 by 2 at square, and third is v square is equal to u square plus 2as. Many students try to use these equations anywhere, wherever they are. No, this is not the case. Remember this, you can use these three equations only when acceleration is constant. So only if acceleration is constant, then you can use this equation to solve a problem. Okay? So what is non-uniform accelerated motion? That type of motion where acceleration is not constant. Where acceleration is not constant. So two type of motion are here, accelerated motion. One where acceleration is constant, second where acceleration is not equal to constant. Acceleration is changing. Where acceleration is changing. So if acceleration is constant, you can solve the problem with the help of these three equations. But suppose acceleration is not constant, then what can you do? Then you are going to use the basic equation. V equal to velocity is equal to ds by dt. You can use this. You can use this acceleration is equal to dv by dt. dv by dt. Or you can use d square s by dt square. Or you can use acceleration is equal to v dv by dx or ds. So if acceleration is not constant, then you are going to use these basic equations. These equations you are going to find out from here if acceleration is constant. So these equations will be for constant accelerated motion, where acceleration is constant, uniform accelerated motion. And when you are going to have a non-uniform accelerated motion, you will go for these basic equations. With the help of these basic equations, we are going to solve the problem, numerical problem. So these two type of accelerated motions are there. Now, graphs. Please note it down quickly. What is the meaning of uniform motion? What is the meaning of uniform motion?
Sir,
Yes.
previous slide, please.
Okay, beta. Please note it down.
Oh, yes, sir.
Okay, beta. Please switch off your mic.
Yes, sir.
So next is uniform motion. What is the meaning of uniform motion? Uniform motion means when a particle is moving with a constant velocity. Simple. If particle is moving with a constant velocity, when you are saying constant velocity, it means magnitude as well as direction of the particle is constant. Particle is moving, ठीक है, magnitude of velocity and direction of the velocity that remains same throughout the motion. Then that type of motion is called as uniform motion. So in case of uniform motion, velocity will remain constant. Particle velocity direction is not going to change. So particle will move along a straight line because direction is not changing. So try to understand particle will move along a straight line. Okay? With a constant speed, you can say. So here particle is moving with a constant speed along this straight line. So that type of motion is called as uniform motion. Beta. Uniform motion. So this is. Next, come to the graphs. Various types of graphs or plots. Okay? So various plots. Okay? So first type of plots which you can observe here, they are x as a function of time graphs. Okay? So first is xt graphs. So here first type of graphs are xt graphs or plots. Rather than graphs, it should be plots, xt plots. Now, one by one, I am going to discuss all type of plots with you. So first maybe this one. On this side, on the horizontal axis, we are having time, and here we are having position. This is 0. Suppose your graph is like this. This graph is given. What is the meaning of this? Means what is this? At at t equal to 0, what is the position? Suppose this is equal to a naught. So at time t equal to 0, its position is a naught. As the time is increasing, its position is not changing. So position of the particle is not changing with time. So what can you observe from here? Position of the particle is not changing with time. Is not changing with time. With time. So what is its meaning? Particle is at rest. So this graph is saying that particle is at rest. I'm going to discuss all type of curves which are possible here. So the meaning of this is that particle is at rest. This is the position. This is, if you are not comfortable with this A naught because we are using, so I can write it as X naught. X naught. So position of the particle is remaining X naught throughout the time, throughout the motion. So particle is at rest. So particle is at rest. Number two. Number two. If plot is like this is time axis, this is X. So here you are having this type of plot. You are having this type of plot. Okay? So what this plot is saying? This plot is saying that X is increasing with time. So what you can observe from here first, X is increasing. X is increasing with time. With time. If X is increasing with time means particle is moving in plus X cap direction. It means particle is moving in plus X cap direction. direction. Second, if you look at the slope of this line, this is a straight line. If you look at the slope, slope is constant. Slope is constant throughout this motion. Particle is moving like this, along this. So slope at every point is equal. If slope is equal, this is a graph between x and t. So what will be the slope here? Slope is what is slope representing here? This is x, this is t. So this will be dx by dt. dx by dt. dx by dt. So basically dx by dt, this is v. So basically here particle is moving with a constant velocity, because if you look at the magnitude of this velocity is same throughout, is constant throughout, slope is same. Second, particle is moving continuously in plus x direction. It means particle is moving with a constant velocity, is moving with a constant velocity. Velocity, v is constant. v is constant. If v is constant, what will be the acceleration? Acceleration, that will be dv by dt. That will be 0. Acceleration will be 0. So what type of motion is this? This is uniform rectilinear motion, or I'm writing uniform motion. What type of motion is this? This is uniform motion. So from this graph, so many conclusions you can draw. So this is a graph that is representing uniform motion. That is representing uniform motion. And here, one more thing here, because x is increasing with time, it means velocity, that is positive. Okay, velocity is positive here also. This is another conclusion you can draw. So these conclusions you can draw from this graph. Is it okay with everyone? Hello.
Yes, sir.
Yes, sir.
Please note it down quickly.
Yes, sir.
Now, third, you can have this type of graph. Here you are having time 0, and here you are having x, and this type of plot is there. So what is happening here? X is decreasing with time. X is decreasing with time. It means particle is moving in minus x cap direction. Particle is moving in minus x cap direction. So particle is moving in minus x cap direction. This is the first conclusion. Second here, look here. Slope is constant. At any point you can observe slope is constant throughout its motion. So here, this was the first conclusion. Second, slope is negative, but slope is constant. Slope is constant. Okay, and particle is continuously moving in minus x cap direction. So here, what can you say? Velocity is again constant. Velocity is constant. If velocity is constant, acceleration is 0. And here, another important thing is, because particle is moving in minus x cap direction, so velocity is negative. This is another ठीक है, another type of graph. ठीक है, so these conclusions we can draw from this graph. Next, please note it down quickly. So fourth, if your graph is like this, a little bit more complicated graphs, here this is x, this is time t. So if graph is like this, if you are having this type of graph, okay, I can make it more. So suppose graph is like this, in this way. Then you are going to tell me, what can you draw from here? What conclusions you can draw from here? So try to understand what is happening here. First, x is decreasing with time. So what is happening? First particle, this particle, it is moving in this direction. Okay? Particle is moving in this direction means its velocity here is negative. Negative. At this point, if you look at this point, slope will be 0. So here, this velocity will be 0. So particle is moving with negative velocity. It is going like this, and somewhere its velocity is becoming 0. Here, its velocity is becoming 0. So particle is move, and after this point, x is going to increase with time. So when x is increasing with time means particle is moving in plus x cap direction. So it will be like this. So here, velocity, that will be positive. Velocity will be positive. So what is happening here? First, velocity was negative, means velocity was like this. Suppose minus 10, it decreased to minus 5, then it decreased to minus 2, then 0, plus 2, plus 5, and plus 10. So what can you predict about its acceleration? Acceleration is positive. Try to understand here. Direction wise, velocity is going to increase. So velocity is increasing. Velocity is increasing. If velocity is increasing, automatically acceleration is positive here. Here, try to understand velocity, acceleration is positive. So here, acceleration is going to be positive in this case. Acceleration is positive. Is it clear with everyone? Initially, x is, look here, x is decreasing. I can write here, this is A, this is B, and this is C. I can say this is point A. Here, somewhere here, it will be B and then C. From A to B, x is decreasing with time. So you can write x is decreasing with time. Decreasing with time. So it means particle is moving in negative x cap direction. So in this case, velocity is negative. Velocity is negative here. And here, velocity becomes 0. Here, slope is 0. So velocity is 0 at point B. After that, x is increasing with time. So particle is moving in plus x cap direction because x is increasing with time. Increasing with time. With time. Okay? Then can you tell me where is the retarding zone and where is the accelerated zone here? Now I want to find out where is the accelerated zone, where is the retarded zone. This is time here. I'm again drawing this. So first, this part, look at this part. This is A to B. If you look at this part A to B, x is decreasing with time. So what is velocity? Velocity is negative in this part. So velocity is negative. Second, acceleration we have proved -10, then it is increasing to -5, -2, 0 with direction. So that's why I can say velocity is increasing. Velocity is increasing. So here acceleration is positive. Velocity is increasing, but look at the speed. ठीक है ना? I'm drawing this zone. If your car is undergoing like this, what will you say? Because direction is negative, that is okay. But speed is going to decrease here. So this is a retarding zone. Here they are going to have opposite sign. Velocity is negative, acceleration is positive. What is this? This is retarding zone. This is retarding zone. Speed is decreasing. If you look at speed, speed is decreasing. Here speed is decreasing. Now come back to the second B to C. This is time, this is X and 0. And if you look from B to C like this part, so here X is increasing with time. So velocity is positive. Velocity is positive. And what is acceleration? Acceleration I have already shown you. 0 plus 2 plus 5 plus 10. This part. This part. Acceleration is positive. So acceleration is positive here. Velocity is positive and acceleration is positive. Means you are in the accelerated zone. Where are you? You are in the accelerated zone. Accelerated zone. You are here in the accelerated zone. ठीक है? Now, remember one thing. This is a type of cusp, or you can say radius of curvature of this graph. That is positive. It is opening in the upward direction. So radius of curvature of this curve is positive. It is opening in the upward direction. So this type of here, if you look at, ठीक है, it is opening. It is also a part of this. If this type of graph is there, try to complete it. Whenever you are having this type of graph, half of the graph is there, then try to complete it. So this cusp is opening in the upward direction. Radius of curvature is positive. So here you can write this cusp is opening in the upward direction. In the upward direction. You can remember this fact. Directly you can write. ठीक है? So radius of curvature. Radius of curvature is positive. Curvature is positive, and whenever radius of curvature or cusp is opening positive, is radius of curvature is positive or this curve is opening in the upward direction, then acceleration is always going to be, remember this, acceleration is always going to be positive. So whenever this type of situation is coming into the picture, then acceleration, that will be positive. Remember this directly without analyzing anything. You can, but graph should be in between x and t only. What is important here? Your graph should be in between x and t only. So if you are drawing a graph between x and t and this type of curve, its cusp is opening in the upward direction and its radius of curvature is positive. Directly you consider that acceleration is positive. Why it is positive, I have already explained you. So please note it down. This is one of the very important graph. Is it clear?
Yes, sir. Yes, sir.
Good. Now, next. Can I go to next?
Yes, sir.
Now, there may be an opposite situation. This is, I think, fifth, if I'm not wrong. If you are plotting a graph between x and t, and your graph is something like this, now it is opening in the downward direction. Okay, so radius of curvature is negative. If you draw its radius of curvature, it will be in the downward direction. Okay, so basically here this type of motion is there, and this is x, this is 0. You're writing a, then b, and then c. So what is happening here? If you look, try to understand here, x is increasing with time. So here from a to b, x is increasing with time. So from a to b, it is like this. This is a to b, and here somewhere here b. At this position, it is going to reverse back. After point B, x is decreasing with time. So here it was positive motion, positive velocity, and now it is reversed like this. This point was B, this point was B, and it is reversed and it is reaching at C. So first, x is increasing with time. So when x is increasing with time, try to understand velocity. Here it is positive. Positive. How I draw this conclusion? Because x is increasing with time. X is increasing with time. At this point B, velocity is becoming 0. Here, velocity is becoming 0. After this particle is moving in this direction, velocity is negative. As x is decreasing with time. Because x is decreasing with time. So this will be, okay? So try to understand, velocity was positive, it is becoming 0 and then negative. So how it will be? Initially, suppose velocity is 10, then it will become plus 7, suppose, plus 3, plus 1, then it will be 0 here at point B, then it will be becoming negative. So automatically it will be minus 1, minus 3, minus 5, like this. So what type of motion is this? This is what will be the acceleration here? If you look with direction, this is decreasing. So from here, I can say my acceleration is negative. Velocity is decreasing with time. What is happening here? Velocity is decreasing with time, plus 10, plus 7, plus 3, plus 1, 0, minus 1, minus 3, minus 5. So acceleration is negative. Now look at this part. This part. First part, A to B. If I look at this part A to B here, this is A and this is B here. This is X, time 0. So because X is increasing with time, velocity I am writing positive. And here 10, 7, 3, 1, 0, so acceleration is negative. So what type of zone is this? V and A, they are having opposite sign. So this is a retarding zone. So what type of zone is this? This is retarding zone. So motion from A to B is retarding. Okay? This is deaccelerated motion, retarding motion. From B to C. If you look at B to C, this is X, this is T 0, and this is B to C. This is B here. This is C here. So what you are observing, X is decreasing with time. So velocity is negative. Acceleration, you look here. Initially it was 0, higher value, decreasing -1, -3, -5. This velocity is reducing with sign. So here acceleration is negative. Both are, but if you look at his speed here, try to understand. In the second zone, in this first zone, speed, if you look at his speed is decreasing. So this is a retarding zone. And here, if you look, his speed is increasing. His speed is increasing. So they are having both same sign, V and A. So this is an accelerated zone. This is accelerated zone. So A to B is retarding motion from here to here. This is retarding motion and here. So basically whenever radius of curvature is negative, so here if curve is opening downward, if curve is opening in the downward direction, in the downward direction, ठीक है, or you can say radius of curvature is negative. Radius of curvature is negative. Radius of curvature is negative. Then acceleration here, that will be negative. So here you have to remember these aspects. Remember this. Remember this case. Is it clear?
Yes, sir.
Yes,
Good.
sir.
Next, 6. Sorry. This is X. This is first part, O to A. Then this is second part. This is a straight line. So this is curvature here. Then a straight line. This is A to B. And from here, it is having a curve. I'm showing you with different colors. This second is this. Next is like this. Yeah, this is curved. Just so here this is curved like this. This is C here, and then this is a straight line, horizontal line D. So these 4 parts are there, and you have to tell me which one is accelerated motion, which one is uniform motion. What type of curve is this? So 0 to A, first you are going to tell me 0 to A. What is this? Here,
Positive acceleration.
yes, beta. For this is the first one, 0 to A. So what conclusion you can draw? X is increasing with time. Try to understand X is increasing with time. So if X is increasing with time, then velocity will be positive. Velocity will be positive. ठीक है? And if you complete this curve like this, then this radius of curvature is positive. It is opening in the upward direction. So what can you say about acceleration? Acceleration here is positive. So what type of zone is this? This is accelerated zone. Motion is accelerated. This is accelerated zone. This is accelerated zone. Second, A to B. If you look at 2, A to B. If you look at slope is constant. At every point, slope is constant. So here, slope is constant. Is constant. ठीक है? And x is increasing with time. And x is increasing with time. Is increasing with time. So particle is moving in plus x cap direction. Direction is fixed. Magnitude is fixed. So velocity is constant. Velocity is constant. Acceleration is 0. So what type of motion is this? Uniform motion. Correct, beta. This will be uniform motion. This will be uniform motion. Third, B to C. Third is B to C. This one, from here to here. If you look at this, I can complete it. Try to understand. This is a curve like this. So if I start continuing like this, so this curve is like this. So it is opening in the downward direction. Acceleration is negative. X is increasing with time. If you look at X, X is increasing with time. So if you write B to C, third is B to C, B to C. X is increasing with time. X is increasing with time. With time. So particle is moving in plus x cap direction. So plus x cap direction. Particle is moving in plus x cap direction. That is fixed. ठीक है? So velocity you can say that is positive. It is in the downward direction. Radius of curvature. Radius of curvature is negative. So A is with minus sign. So one is positive, one is negative. This is a retarding zone. What is this? This is a retarding zone. And this fourth one here. If you look at this is a horizontal line, means position is not changing with time. X is not changing with time. X is not changing with time. It means particle is at rest. Particle is at rest. So these are all type of graphs I have discussed regarding XT graphs. So all type of XT graph possibilities I have discussed with you here.
Sir,
Yes, beta, please.
I can't understand B to C.
B2C. Okay, B2C, this one. Okay. So B2C. First look at this graph, beta. What is happening to X? X is increasing with time. Okay. Try to understand time is increasing in this direction and X is increasing like this. So it is moving up, 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 and up. So if X is increasing with time, then particle is moving with plus X direction, plus X cap direction. If particle is moving in plus X cap direction, then I can conclude V is positive. V will be positive if particle is moving in plus X cap direction. Second, what will be the acceleration? Look at this curve. This is having a curvature. If I completed this curve, this is a curve that is opening in the downward direction like this. This is a part of this curve. So it is opening in the downward direction. Radius of curvature is negative. So acceleration is negative. I have already told you how to find out radius of curvature is positive or negative. So it is opening in the upward direction. Acceleration is positive. It is opening in the downward direction. So acceleration is negative. So V is positive, A is negative. So this is a retarding zone. ठीक है, this motion of the particle from B to C, this is retarding motion. So here this is accelerated motion. This is uniform motion. Second, uniform motion. This is retarding motion. And this is uniform motion. This is uniform motion. So in this way, you can explain this curve. Is it clear now?
Yes, sir.
Good. Next is velocity time graph. Second type of graphs, they are velocity time graph. Now come to second type of graphs. Please note it down quickly. Next is velocity time graph. Next is velocity time plots, VT plots. Velocity time plots or curves. ठीक है? First, simplest. Suppose on this is first one, velocity as a function of time here. Velocity as a function of time. So if your plot is a horizontal line, try to understand this is 0. So all the velocity is above this horizontal line, they are positive. So what is this horizontal line? Actually, this is representing some velocity like plus V naught. Okay, whatever velocities will be here below this line, there will be negative velocity. Negative velocities will be here, positive velocities will be here. So this is a positive velocity. This is a positive velocity. Particle is moving in plus x cap direction. That's why this is positive. So first is positive velocity. Positive velocity. First conclusion. Positive velocity. Second, this is a constant velocity. V naught is constant. Constant velocity. Constant magnitude, you can say. Magnitude. So what you are going to have? You are having V. Magnitude as well as direction is constant. So V is constant. So acceleration will be 0. So this will be a uniform motion. What it is representing? This is representing uniform motion. So this plot is representing uniform motion. One thing you have to remember, here you are having positive velocity and below this line there will be negative velocities here. Here negative velocities. On and above this line, they will be all positive velocities. So keep this in mind always. So this is positive velocities. This is negative velocities. It will be like this. Okay? Positive velocities and negative velocities. In this way, you can remember. This is the first graph. This is the first graph. Second, the time. This is V here, this type. So what type of, where is this plot is in the positive side. This is above the time axis. This is 0. So velocity is positive. So first is whatever velocity is positive. Positive. And acceleration, velocity is increasing with time. Try to understand velocity is increasing with time. So here if you look at second, you can say velocity is increasing with time. Is increasing with time. So A is positive. Second, slope is also positive. So slope is also positive. You can look at both. Slope is positive. So what you are saying velocity is positive. And these two facts, they are saying me that acceleration is positive. Acceleration is positive. ठीक है? Or acceleration is not only,
Constant. Slope
sorry,
is
just 1 second. Acceleration is constant. Acceleration is ये जो slope is positive and constant. So ये क्या है बेटा? This is and acceleration is positive also. Try to understand. ठीक है? Acceleration is not only constant in magnitude. Magnitude wise it is constant, and acceleration uh, slope
Sir,
because yes beta please.
here B is constant, so A is equal to 0, right?
Where v is not constant, v is changing with time, na? This is velocity here. This it is not x. Now
Okay, sir.
it is v. So slope of v and t, ठीक है ना? That is
Okay,
give slope of this will give you the acceleration.
okay,
ठीक है?
sir.
So this is a accelerated motion. So try to understand acceleration is constant, as a student was saying that slope is constant, so acceleration is constant. But slope is also positive, so acceleration is also positive. So what type of motion is this? This is because this is constant also, so this will be uniformly accelerated motion. Uniformly or uniform accelerated motion, because v is positive, a is positive, so this is accelerated motion. Uniformly accelerated motion. This will be uniformly accelerated motion. Is it clear with everyone? Because slope is constant. Okay, so magnitude is constant. Slope is positive. Or you can say velocity is increasing. So A is positive because velocity is increasing with time. You can say velocity is increasing with time. So acceleration is positive. And because V is positive, A is positive, so accelerated motion. Because this acceleration is constant in magnitude, so this will be uniformly accelerated motion. Okay? Uniformly accelerated motion. Next is this is T here. This is V and 0. If you are having this type of. So try to understand this. This is here. This plot is here above this axis. So V is positive. V is positive because this graph is above this axis. So V is positive. Second, here slope is negative or velocity is decreasing with time. So acceleration is negative as V is decreasing with time. Decreasing with time. So, and if you look at slope is constant, so this magnitude is constant. Constant. Why? As slope is constant. Slope is negative but constant. So V is negative, V is positive and A is negative. And it is so A, this is saying uniform, and these two, they are combinedly saying uniform retarding motion. This is uniformly retarding motion. This is uniformly retarding motion. Is it okay?
Yes, sir.
Good. Next. And this was, I think, third, no? Or what is third and fourth now? Come to the fourth. Suppose your graph is like this. So whatever possibilities may be there, I'm trying to cover all the possibilities V, and this is 0. Suppose here you are having this type of graph, is this type of graph. So what is happening here? Please tell me. Velocity is positive or negative, because this
Negative.
this is negative. Very good, beta. Negative. V is negative. Negative. What is acceleration? What type of slope is it is having?
Positive.
This is positive. So this is positive. As slope is positive. As slope is positive. So here, and acceleration slope is constant also. As slope is constant. So this will be, magnitude of it will be constant. So this will be uniformly formally retarded motion. This is uniformly retarded motion. ठीक है? Uniformly retarded motion. Then next 5. This is time t, this is v, this is 0, and it is like this. This. It is like this. So what is velocity? Velocity is negative. Velocity is negative. If you look at acceleration, slope is negative, so this will be negative. So what type of motion will be, as well as slope is constant? So this is constant, magnitude is constant. So this will be uniformly accelerated motion. This is uniformly accelerated motion.
सर
Yes, बेटा बोलिए.
नेगेटिव डायरेक्शन में एक्सेलरेशन को ही डिसेलरेशन कहते हैं क्या?
No. Both velocity as well as acceleration, if both are negative, only then you can say, for example, here, what is velocity? Particle is moving in this direction. Try to understand. Negative velocity means particle is moving in this direction, so velocity is negative. First thing. And how velocity is changing? What will be the velocity here? This will be, suppose, -1, then -2, -3, -4, -5. So here, at this point, this was -2, then -3, -4, -5, -6. If you are moving in the car in this direction, and velocity of your car is moving to -2, -3, -4, -5, means speed is increasing. If you look at its speed, so speed is increasing. Speed of your car is increasing. Is increasing. So what type of motion will be? This will be accelerated motion. This will be accelerated motion. So you have to look at the speed. If you want to make it very, very simple, look at the speed. Speed is increasing or speed is decreasing? Speed is increasing, okay? Then automatically acceleration is taking place. If speed is decreasing, then automatically retardation is taking place. Is it clear what I am saying? Hello?
Yes,
Yes.
sir.
Yes, sir.
Good. Next. This is fifth, then sixth. This is time here. This is V here, 0. And if you are having something like this, okay, you are having this type of. So what is V is positive first? What is this? V is positive. V is positive above this axis. Second, V is increasing with time. V is increasing with time. So acceleration is positive. Okay, acceleration is not constant. Slope is changing everywhere, is not constant. So just you can say, this is a non-uniform, this is a non-uniform accelerated motion. Okay, so this is a non-uniform, non-uniform accelerated motion. This is non-uniform accelerated motion. Number 7, it is time t. This is v. This is o. This is so. Okay. Then suppose for having this type, this is. So what is happening here? V is positive. So here V is positive. Positive. V is decreasing with time. So acceleration is negative. Deaccelerated motion, retarded motion, non-uniform. Retarded motion. This is non-uniform. Non-uniform retarded motion. This is. Okay? So these are most of the graphs of velocity and time. So velocity as a function of time. These are the graphs. For acceleration, okay, for acceleration, it may be like this. If you plot, so not so many graphs are there. You may find out only this is if you are having. So acceleration is positive here. This is 0. So acceleration is positive. And second, magnitude of this is positive, is constant. Okay. So this will be uniformly, A is positive here. ठीक है, तो A पॉजिटिव है, so मोशन कैसा होगा बेटा?
Sir,
यूनिफॉर्मली. यस बेटा
why
प्लीज.
A is positive?
हम्म. Pardon?
Why is A is positive?
Because it is above this line. Try to understand here. You will have positive accelerations. ठीक है? And below this time axis, you are going to have negative accelerations. ठीक है? Second, if acceleration is positive, it means velocity is increasing with time. So these information you can draw from here. So from here you can draw these Uniform acceleration you can predict, and velocity is increasing with time. Okay. Second, this was which one number? This was eighth, or yeah, first you can say. This is first acceleration time graph. Acceleration time graph. Acceleration time graphs. Second, this is time, this is 0. This is acceleration you are having, and your plot is here. So from here, you can say acceleration is negative. I just can say acceleration is negative. Second, magnitude of acceleration is constant. I can say this. And because acceleration is negative, velocity is decreasing with time. Velocity is decreasing with time. So I can draw only these conclusions from these graphs. Okay? From this graph, I can draw this conclusion. There is one another graph, that is velocity Vx graph. Next is, last type of graphs are velocity distance graph. ठीक है ना? V as a function of x graphs or plots. Suppose this is first one. I'm just here you are having x. This is 0. This is velocity. This is v. And you are having this type of graph. This type of graph you are having. This is v naught. And I say this is x naught. Okay? This graph is given. Okay? Now what you have to do? You have to find a plot. What you have to do? You from this you have to find out acceleration. Okay? First, what you have to do? You have to find the expression of acceleration, or you can say plot A versus x. I need this graph. A versus x graph. Acceleration as a function of distance. Acceleration as a function of x. I need this graph. How can you find out? This is a very good question. This can be any time in any exam. So, what is this slope? What will be the slope here? Slope A will be equal to the slope. Very simple. ठीक है ना? This will be. Can you tell me what is the slope here? I want
PGT
Negative.
ठीक है ना? So what I want to, can you plot this curve? This will be V. This will be V here. And if V is there, या इसे हटा देते हैं अभी for the time being.
-8.
हाँ, just V equal to minus slope is negative. Perpendicular is V naught. Horizontal distance is x naught. Horizontal variable is x. And this will be C कितना होगा इसका? You can write here C if you cannot calculate. At x equal to 0. At x equal to 0. V is V naught. So V is V naught. And this will be 0 plus C1. So my plot will be this. This V will be equal to minus V naught upon X naught. into x plus v naught. So first I write the equation for this line, whatever line or plot is given. In this case, first I have written this one. First I have written this one. Now I need acceleration. Now I need acceleration. Acceleration batao beta. Actually, that was whatever I have written acceleration is slope, that was wrong. When it will be the slope will be acceleration when you are plotting velocity as a function of time. But here this is
X
velocity as a function of x. So slope will not be equal to the acceleration. So this is v as a function of x. So what will be the acceleration? Acceleration I
X
have given you
into dx.
v into dv by dx. I have given you this formula of the acceleration. So write this v, that is minus v naught upon x naught. This will be x plus v naught. And dv by dx, dv, what will be dv by dx from here? dv by dx, that will be minus v naught upon x naught. So this will be minus v naught upon x naught. So a will be v naught square upon x naught square into x, and minus this will be v naught square upon x naught. Can you plot this a as a function of x? ठीक है, can you plot this a as a function of x? Yes, we can plot. How? So first, here we will have x, here we are going to have acceleration a. Try to understand at x equal to 0. At x equal to 0, a will be negative. So it will be somewhere here. And this point will be minus v naught square upon x naught. ठीक है? And when a is 0, x is positive. So it will be somewhere here. So you are going to have this type of plot. ठीक है? So acceleration as a function of time. ठीक है ना? This will be the plot. This type of plot will be there for acceleration as a function of time. So this type of question may be there. ठीक है? So I have discussed each and every aspect of the motion
Sir,
along a straight line. Yes, beta.
can you please teach this again?
You go try to understand here. This is velocity as a function of x. I want to find out acceleration. I want to find out acceleration, or I want to plot acceleration as a function of x. This is my objective. So acceleration, if you are having a graph between v and t, v as a function of time, then slope will be equal to the acceleration. But here, slope is not equal to acceleration. So what I do, I write a equation for this straight line. What it will be? What will the slope here? This is perpendicular part divided by horizontal part. Perpendicular part is v naught divided by horizontal part x naught. This is v naught by x naught. And negative slope is there, so minus sign is there. So this is the slope here of this line. So v equal to slope into x plus constant, some constant c1. At x equal to 0, v is equal to v naught. So at x equal to 0, v equal to v naught. I place here 0. So v naught is equal to c1. So c1 is v naught. I place here and I find out the equation of this straight line. This is v equal to this one. What will be the acceleration? Acceleration, one of the formula for the acceleration is this. A is equal to v dv by dx. In place of v, substitute this one. I substituted here. dv by dx will be minus v naught by x naught minus v naught by x naught. Multiply here, and this will be the equation for the acceleration. At x equal to 0, a will be negative. So at x equal to 0 here, okay, x equal to 0 here, acceleration will be negative, so it will be somewhere here. If you place A is 0. If I place A is 0, then X will be some positive value. So it will be some positive value. So this will be line, this is straight line. This is going to represent acceleration as a function of X. This will be the formula for the acceleration. And this is the plot of acceleration as a function of X. So in this way, you can plot this curve. So I have discussed every aspect of motion in a straight line. Okay. A part is left where relative motion we have to study, but that I will do in 2D motion. That I will do in 2D motion. So you are having a booklet. From the booklet, you can solve the questions of 1D motion. In the next class, first, I will explain projectile motion. Try to understand. I will start with projectile motion. Actually, in kind, I just 1 second. So actually, whenever we are studying kinematics, so here, okay, first this will be 1D motion, and here there will be 2D motion. 2D motion, particularly in 2D motion, two topics are there: projectile motion, and then relative motion. Okay. Third is circular motion, but circular motion I have already covered. Okay, that topic I have already discussed. So here I'm going to discuss projectile motion and relative motion, and after that I will discuss their questions of 1D motion, projectile motion, and relative motion. Okay. So in this way, first section will be completed. After that, you are going to have Newtonian mechanics, Newton's laws of motion, friction, work energy. So all these topics I am going to do. Okay, beta. Thank you very much. Good night.
Thank you, sir.
Welcome, beta.
Sir,
हाँ जी बेटा, please.
sir, when we start with special theory of relativity next year,
We will inform you. Right now, I cannot say, but surely we are going to discuss. I will inform you the time after discussing with the management.
sir, for
Sir,
the topic recorded class is uploaded. We want
Yeah,
to see that recorded
okay.
class or a live session will take.
I will take a live session also, but you can study from the recorded. I will say, I will discuss with Satyendra ji, okay, that he will upload those STR lectures in your Google Classroom. ठीक? So you can study yourself also from the recorded lecture, and I will also try to take those classes again, live classes.
sir,
Yes, beta.
वो
बोलिए please.
retardation और deceleration words
They are
same
same.
same
They are
होते हैं
same.
क्या? Okay.
Retardation as well as that deceleration. They are same.
Okay.
Okay, beta.